Okay, we're going to look at some rate of change questions. We're looking at the gradient of the tangent at a particular point. So example 1, find the rate of change of y equals 5x cubed minus 2x to the power 4 at x equals 2. So rate of change is telling me to differentiate. So that's dy by dx is equal to 15x squared minus 8x cubed. So that's the gradient. I'm now looking at the gradient when x equals 2. So that's 15 lots of 2 squared minus 8 lots of 2 cubed. So 2 squared is 4, times that by 15 is 60. Minus 2 cubed is 8, 8 times 8 is 64, 60 take away 64, and that is minus 4. Okay, let's try another. We're going to find f dash 2 when f of x is equal to x cubed plus 4x squared plus 1. So first of all, differentiate. That'll be 3x squared plus 8x. Now sub in 2, so that'll be 3 lots of 2 squared plus 8 lots of 2. So 2 squared is 4 times 3 is 12, plus 8 twos are 16, and that'll be 28. Okay, this time find g dash minus 2. G of x equals 4x to the 5 minus 2x cubed minus x. So let's first of all differentiate. So that's going to be 20x to the 4 minus 6x squared minus 1, and sub in minus 2. So it's going to be 20 lots of minus 2 brought to the power 4 minus 6 lots of minus 2 squared minus 1. Okay, so minus 2 to the power 4, well that's minus 2 times minus 2 times minus 2 times minus 2, take your time, that'll be 16. 16 times 20 then is 320. Minus 2 squared is 4, times that by minus 6 is minus 24 minus 1, and that will be 295. Okay, next one, find the rate of change when y equals 1 over 2x squared plus 5x cubed at x equals minus 1. Okay, so let's prepare to differentiate. That's going to be a half x to the minus 2 plus 5x cubed, and differentiate. So minus 2 times a half is minus 1, so that's minus 1x to the minus 3 plus 15x squared. Let's now tidy that up so that we've got a positive power, and that'll be minus 1 over x cubed plus 15x squared. We're now looking at x equals minus 1. So that's minus 1 over minus 1 cubed plus 15 lots of minus 1 squared. So it's minus 1 over minus 1. Minus 1 squared is 1 times 15 is 15. So that's 1 plus 15, and that is 16. Okay, next one, find the gradient of the tangent. So again, that's another phrase that's telling me to differentiate. Find the gradient of the tangent of f of x equals 2x cubed minus x squared at x equals 3. So let's differentiate. That'll be 6x squared minus 2x. F dash 3 is 6 lots of 3 squared minus 2 lots of 3. So 3 squared is 9 times 6 is 54 minus 6, and that is 48. Okay, let's try another. And we've got f of x equals 6x to the 3 over 2, and we're looking for f dash 1, and then let's try f dash 1 quarter as a separate question. Okay, so let's differentiate. So 3 halves times 6 is going to be 18 halves. 18 divided by 2, that's 9 x to the 1 half, and that's because we've got 3 over 2 take away 1, which is 3 over 2 take away 2 over 2, which is 1 over 2. I can then introduce the root symbol, so that's 9 lots of root x. So f dash 1 then would be 9 lots of root 1, which is 9. And for f dash 1/4, that would be 9 lots of the square root of 1/4. So that's 9 multiplied by the square root of 1/4. Well, root 1 is 1, and root 4 is 2, and that is 9/2. Okay, find the gradient of the tangent to y equals 4 lots of the cube root of x minus 2 over the cube root of x at x equals a. Okay, so let's first of all prepare to differentiate. That's going to be 4x to the 1/3 minus 2 over x to the 1/3. That's 4x to the 1/3 minus 2x to the minus 1/3. And then differentiate. Bring the power down, multiply, take 1 away from the power. 1/3 times 4 is 4/3. X to the minus 2/3. Then minus 3rd times minus 2 is going to be plus 2/3. X to the minus 4/3. So that's going to be 4 over 3x to the 2 over 3 plus 2 over 3x to the 4 over 3. I can then introduce the root symbol, so that's going to be 4 over 3 lots of the cube root of x squared plus 2 over 3 lots of the cube root of x to the power 4. Okay, we were then looking for the gradient of the tangent x equals 8. So it's going to be 4 over 3 lots of the cube root of 8 all squared plus 2 over 3 lots of the cube root of 8 brought to the power 4. So that's 4 over, well, the cube root of 8 is 2. 2 squared is 4. 4 times 3 is 12. Plus 2 over cube root of 8 is 2. 2 brought to the power 4 is 16. 16 times 3 is 48. So that's 1/3 plus 1 over 24. And that would be 8 over 24 plus 1 over 24, which is 9 over 24, and I can simplify that. Top and bottom by 3 will give me 3/8. Okay, we're going to try a couple of questions in context. So let's go for the distance travelled on a roller coaster is calculated using the formula d equals 10t squared minus 5t, where t is the time in seconds after the start of the ride. Calculate the speed of the car in the roller coaster after 3 seconds. Okay, so speed being the rate of change of distance. So differentiate, and that will give me 20t minus 5. I'm then going to sub it in t equals 3 because we're interested in what's happening after 3 seconds. So that will be 20 times 3 minus 5. That's 60 take away 5. And that will be 55 metres per second. Okay, the circumference of the largest ripple on the surface of a pond after a stone hits is given by the formula c equals 2 pi times root t. Well, t is the time in seconds after the start of the experiment. Calculate the rate of change of the circumference 4 seconds after the stone hits. So t is equal to 4 seconds. So let's first of all prepare to differentiate. That will be 2 pi t to the half. Okay, so differentiate. A half times 2 is going to be 1, so it's going to be pi t to the minus 1/2. Let's tidy that up so we can substitute in. That will be pi over t to the positive 1/2. Remember that the square root of t is t to the half. So that can now be written as pi over root t, and then I'm going to sub in t equals 4, and that's pi over root 4, which is pi over 2. Okay, next one. The current I in amps in an electric circuit is given by 200 over R, where R is the resistance in ohms. Find the rate of change of I with respect to R when the resistance is equal to 10 ohms. Okay, so first of all, let's prepare to differentiate. That will be 100 R to the minus 1, and then differentiate. minus 100 r to the minus 2. So let's get a positive power so that we can sub in minus 100 over, bring that down, r squared, and we're looking at the calculation when r is equal to 10. So that's minus 100 over 10 squared, that's minus 100 over 100, and that is equal to minus 1. Okay, next one, the amount of drug in milligrams in the bloodstream at any time t minutes after administering the drug is given by A equals 400 root t minus 25t. Find the rate of change of the drug in the bloodstream after 64 minutes. Okay, so let's prepare to differentiate first of all. So 400 t to the half minus 25t, then differentiate. Half times 400 is 200, so it's 200 t to the minus 1/2 minus 25. Okay, so bring the t to the minus half down, that will be t to the 1/2. Okay, so that's 200 over root t minus 25. I'm then interested in what's happening after 64 minutes. So that's 200 over the square root of 64 minus 25. Square root of 64 is 8, so it's 200 over 8, take away 25. So it's 25 minus 25, and that's 0, so there's no drug left in the bloodstream after 64 minutes. Okay, let's try one more. The volume of water in millilitres which overflows from a weir is calculated using the formula V is equal to 5h to the power 3 over 2, where h is the height in millimetres of the water above the weir. Calculate the rate of overflow when the height is 900 millimetres. Okay, so 3 over 2 times 5 is 3 halves times 5 is 15 halves, and that's h to the power 1/2. And why is that again? Because it's 3 over 2 take away 1, 3 over 2 take away 2 over 2, which is 1 over 2. Okay, so that's 15 over 2 lots of the square root of h. We're then subbing in 900, so that's 15 over 2 lots of the square root of 900, which is 15 over 2 times 30. That's then 450 over 2, which is 225.